Now, given a conditional statement, if P then Q, we can derive three other types of conditional statements. The very first one of which is the contrapositive. We will also talk about the converse and the inverse. So what is the contrapositive of P implies Q? The contrapositive of P implies Q is not Q implies not P. So what you should notice here is that we're flipping the P and Q locations and also negating both of the variables. And we can demonstrate and we can prove using a truth table that P implies Q is equivalent to the contrapositive not Q implies not P. This is one of the most fundamental laws of logic in this class. And I'm going to ask you to demonstrate the equivalence by making the truth table to show that these two statements are equivalent. So think about what your truth table looks like. First of all, how many rows? And second of all, how many columns? So we need basically 4 rows because we have two letters P and Q. We also need to have a column for the implication itself. We also need a column for not Q, a column for not P, and a column for the total not Q implies not P. So this is what the table is going to look like. And again, we filled it using the implications and using the negations, rules that we have learned. So notice that the column 3 and column 6 are equivalent. In other terms, the truth values in column 3 and column 6 are the same. This is the reason why we can say that P implies Q is equivalent to the contrapositive, not Q implies not P. The next two conditionals that can be derived from the original P implies Q are called converse and inverse. So what is the converse of P implies Q? It is Q implies P. So notice it's similar to the contrapositive, except it doesn't have the negations of Q and P. It just reverses the letters, but it doesn't negate them. Now, what about the inverse of P implies Q? Well, as you can see here, the inverse is not P implies not Q. So it doesn't flip the P and Q locations, it just negates them and it leaves them in the same spot. And we also know that the converse and the inverse are equivalent to one another. That's what's written on the bottom over here. Q implies P is equivalent to not P implies not Q. And we're going to do that again using a truth table. So pause the video here if you can and try to mimic what we did on the last table to determine whether these two are equivalent or not. They should be equivalent, so your truth tables should be the same. So here's my truth table. Again, I constructed it using the same rules that we've been discussing, implications and negations. And what's useful to notice here in this table is that the columns 3 and columns 6 are equivalent.